part 2 of this video. We now are going to discuss normality, the famous bell curve. In statistics, normality means your data forms a symmetrical, bell-shaped distribution. Think of measuring heights. Most people are average, with fewer very tall or very short. This bell curve pops up everywhere. IQ scores, blood pressure, exam results. The most common values cluster in the middle, with fewer at the extremes. Many statistical tests, like t-tests and ANOVA, assume your data is bell-shaped. These tests are designed for this shape, like a key made for a specific lock. If your data is bell-shaped, the test works perfectly. If it's skewed or lumpy, the test can give you bad results. So before using these tests, check if your data fits the bell curve. It's a simple step that protects your conclusions. Don't skip the shape check. Checking for normality is easier than it sounds. Start with a histogram, a bar chart showing how often each value appears. If the bars form a bell shape, your data is probably normal. Another tool is the QQ plot, which compares your data to a perfect bell curve. If your points fall along a straight line, your data is normal. If they curve away, your data isn't normal. For a more objective check, use a normality test like Shapiro-Wilk. Look at the p-value. If it's above 0.05, your data is normal enough. If it's below 0.05, your data is not normal. A small p-value is a red flag. Don't ignore it. Use visuals and tests together for a clear answer. These checks are quick and essential. They help you choose the right analysis. If your data isn't normal, don't worry, you have options. First, use a non-parametric test, like Mann-Whitney-U or Kruskal-Wallis. These tests don't care about the shape of your data. They're robust and reliable for weird or skewed distributions. For every common parametric test, there's a non-parametric alternative. Another option is to transform your data, using a log or square root to make it more bell-shaped. After transforming, check normality again. If it works, you can use the standard test. If not, stick with non-parametric methods. Using the right test matters. Parametric tests are powerful, but only if their assumptions are met. Using the wrong test risks false positives or negatives. Always match your analysis to your data's shape. That's how you get reliable, meaningful results. Let's recap. The shape of your data matters, just like the shape of a cake tin. We covered 2 key assumptions, linearity and normality. Use scatter plots to check for straight line relationships. If your data curves, use a curvilinear test or transform your data. For normality, use histograms, QQ plots, and normality tests. If your data isn't bell-shaped, use non-parametric tests or try a transformation. The most important step is to look at your data before running any analysis. Make pictures. Get to know your data's personality. Is it straight or curvy? Bell-shaped or lopsided? Answering these questions sets you on the right path. Don't be intimidated. These checks are the heart of good research. Respect your data, choose the right tools, and your results will be trustworthy. Remember, check your tin before you bake, and look before you leap into analysis.